Okay. Hello, everyone. Great to have you on the new episode of our AI office hours. We have today Dad and Henry. I'll let them introduce in a second. Hope you're going to enjoy the conversation. Dad, do you want to kind of introduce and then Henry?
Yeah, sounds good. Thanks, Illia. Really nice to see you all. My name is Datno. I'm an AI architect here at Arize. Maybe a little bit about myself. I guess I was a data scientist for a long time. Was a software engineer before that. I built a lot of, you can think, classic ML. Nowadays, you'll catch me really building, architecting with a lot of our customers here at Arize. So if you don't know what Arize does, we're a kind of AI observability platform. So I work very closely with some pretty amazing teams like Uber's customer obsession team, Spotify DJ, booking a lot of the airlines, but a lot of folks building in the Gen AI space. So really nice to be on the show.
Cool. Yeah, I can continue. So I'm Henry. I'm the CTO of NetMind.AI. So a little bit more about NetMind. So NetMind is a decentralized machine learning platform offering a variety of AI services, and we build on top of a decentralized and distributed GPU infrastructure. So I need engineering team at NetMind.ai focusing on building infrastructure and AI services. Prior to NetMind, I spent over 10 years in software engineering industry. So I work at Microsoft and Coinbase prior to NetMind. I'm also excited to be here with NEAR.AI for AI discussion.
Awesome. Well, great to have you, and hopefully we have interesting discussion for us and everyone watching. Maybe to kick it off, I don't know that you've sent a few topics beforehand, so I'm curious if you have like specific questions. We can zoom in.
Yeah, I had some fun topics that I think we might chat about. Maybe I'll just bring up one and we can just talk about it. But I think one, like, I don't know if y'all been watching the markets recently, but yeah, I was curious, your opinions on, and I'm happy to share mine as well. AI ROI, and then the current market conditions that we're in. When we think about spend versus return, where are we at in that kind of life cycle? I think people want to have a conversation. Are we in a bubble or are we not? But I'd be curious to hear y'all's opinions first. I have plenty of opinions, and I'm not a guy, so but really excited to hear kind of what you guys are thinking in the space. AI ROI.
Yeah, I mean, it's definitely a complicated question, right? Because I mean, I kind of similar to you guys worked on machine learning stuff for a long time, where this was not a question because you usually applied machine learning already when you have a business, right? And you have clear ROI. And now we have this kind of race to the top of who's going to have the biggest cluster, who's going to have the biggest model, which is akin to building out kind of internet superhighways back in the day, and some other like infrastructure build outs, like railroads is a good example in the beginning of the 1800s. And so I think on one side, AI, I do think is a very transformational technology, right? And kind of what we envision is something that, gonna change how we, work and live fundamentally. But it's unclear what's the timeline of that, right? Similarly, how it was unclear, 5 years and 10 years ago. It's been very much kind of faster than skeptics think, and slower than optimists like me would like to. And so I think we're in similar stage right now, where everybody's kind of really building on infrastructure, but the skeptics are like, when is the revenue going to come from, right? It's like the generative AI is going to always be just mimicking and parroting the statistical data, and this is going to be how it works, and this is not going to give us much. And then the optimists are like, hey, like we're using it every day. This is like super awesome, but obviously there's still like some fundamental limitations. And so I think that the truth is somewhere in the middle. And so sadly, the big companies right now are the ones who can stomach that spend because they actually don't have anything else to spend productively money on. And smaller startups are not, and they're being bought out right now, right? Or more like licensed and hire people. So yeah, I think that that's kind of the state we are right now. And then one more item, like I'm more optimistic about newer companies that have built AI first than adopting kind of AI in existing like bigger enterprises. And that's mostly because like the adoption in enterprise is extremely hard. And some of the things that AI is really good at is kind of requires re-engineering how things are done and kind of sometimes putting person as quality control versus the doer. And so like you kind of need to change the processes and models. And it's fine for a new startup who is like thinking in that way. And it's really hard when you kind of need to like undo everything while you have business running forward, right? And you have kind of a lot of political and kind of personnel questions to answer. So that's where my other like people expect enterprise to pay a bunch of money for this stuff, and I'm just like, it will be some, but it will not be as much, and it will become from this new startup just growing faster because they're like so much more productive. You know, that's kind of a few points there. Henry.
Yeah, so that's a really interesting topic and question. So I do have some ideas for ROI in AI. So because like I work at infrastructure and cloud computing industry for lots of years, right? So it's similar with the cloud computing about like 20 years or 15 years ago. Like for example, AWS, right? So when the cloud computing at their early stage, it's also a really sort of a big investment for the company to spend lots of money building the computing power, machine pool, data centers, and infrastructure, cloud infrastructure. And at that time, people have no idea how cloud computing can evolve and how their uh, investment can eventually turn into the revenue. And but they still like spend lots of time, including hardware, software, and also engineer and all those kind of stuff. But eventually, like AWS, Azure, GCP, they win, and it's sort of like has similarities with like AI nowadays. So you don't know how AI can evolve and can have like impact or the potential revenue in the future or in like 2, 3, 4, 5 years. But like big companies like Meta and Microsoft, they spend tons of money investigating in AI. So like we know like AI is a really really big thing, but we still unclear what's the next like big point, like sort of like um, revolutionary point that could happen and could change the industry, can change the world. So and also like I think the biggest investment in AI now has like several like can includes like for example GPU power. Like for example, if you want to train a really big model like Llama 3.1, like they require massive GPU clusters, and all those GPU are really high brand like H100, right? So this is actually a really really big investment. I don't think like a small or medium-sized company or startup can afford this. And also like investment on the scientists and research can also be very expensive. Like sometimes like you put lots of effort on research, it like cannot guarantee you get the like the outcome that you are like happy with, right? So, but eventually, like if you find something like ChatGPT, right, it will just like explode, and you just like get into next stage. So I would say like because like at NetMind, right, we work with lots of small startups like because they also need GPU computing power, right? The span of or the cost of GPU is pretty expensive, especially for small startups, right? So they are not they are more willing to use our GPU instead of using the cloud platform because we offer much cheaper and easy access, a much cheaper price and easy access for the GPU. So in their perspective, they have different stages. Like initially, they want to build their model, train their model, fine tune their model, and also work on POC, MVP. So at this stage, they don't need to spend lots of money. So they just use the a small portion of GPU resources in our platform. And when they want to scale, they can sort of like decide or to use a large amount of GPU or GPU clusters. So for this one, like I think the conclusion is like they need to play safe and eventually sort of like to know their product and know their customers and then decide which kind of investment they want to spend in AI and then eventually to sort of like grow their business, grow their customer base and get the return. So yeah, so overall, like I think it's complicated, but I don't know if there is a model or algorithm for ROI in AI for now. But I think like for them, like some key factors are sort of like cost savings, revenue growth, and also decision making depends on the market, depends on the product feedbacks. Yeah, that's my thoughts.
Awesome. Love the takes here. Yeah, I think I'll play devil's advocate to Ilya's point. I do think you'll have some super high growth startups, Ilya, that like they're AI first and they're like the recent YC batches or wherever they're coming from. But I do think like, so I work very heavily in the enterprise space, right? Observability, all that stuff. I do think like the startups will move faster, but I do think there's like a distinct advantage because it's like, it's not just AI that gives you a competitive advantage. It's like AI plus data, right? Because like at the end of the day, I think we all have access to the same AI, right? It's like GPT 4.0 if you consider that the best, or Sonnet 3.5. So I do think it is like it will be interesting to see. I do think there's a lot of parallels between like the .com boom, right? It's like some companies took advantage of the internet, but you had a lot of winners that came out of kind of nowhere. The people who I guess didn't adapt, and I do think bubbles are good. I think like with the recent like call, the investor call, like I think with Google and Sundar just like talking about, hey, you're spending a lot of capex into AI, and then their stock price took a nice 8% drop. But I think I agree with his take, and I think Zuck said the same thing. But I think it is more risky to underinvest rather than like overinvest here. And I think the take is like, I think Ilya's right, and I think you're right too. Is like we're still so early stage, right? We're still like, I think the ROI part of AI, like ignoring like the money aspect, but if I like zoom out on what we're actually trying to achieve, it's either unlimited human capital, right? So like, like you can think your economy explodes significantly because all the knowledge work is being kind of delegated out. So that's one part of the ROI. I think the second part is something a little bit deeper that we haven't really been thinking about. It's like new knowledge. I've yet to see an AI produce like like
New
PhD
research,
level. Yeah. Yeah, exactly. But could you imagine a world where that's true? And it's like, we haven't gotten there yet, but that's like,
well, so there is actually some of that. It's just not in purely generative AI space, right? Like a friend of mine worked on material design, machine learning, right, where they pretty much can score material molecules ahead of actually trying to compose them to understand their properties, and so like they could filter down to. Similarly, one of the co-authors of Attentions All You Need is doing this for kind of drug design, where you could actually predict what are the possible kind of impact of specific mRNA and how it will affect different proteins, and then you use that like AlphaFold as well. So I think like we have that in specialized fields right now. It's not a generic like come up with new stuff and it goes and like does that, right? You kind of have a specialized models right now. But if anything, we've learned from the past few years is that like, well, if you train on a bunch of these things at the same time and maybe mix in some of the search machinery, it can actually start cross learning and finding interesting examples. And so yeah, I mean I'm excited about combination of kind of generative like model and some form of search, and then some of a form of environment, be that real world or simulated, where it can actually test its hypothesis. And so the IMO prize thing, right, from DeepMind is kind of a good example of that.
Yeah, totally. I was just saying I work with a lot of biotechs, and they're definitely in the deep ML space on that stuff. But I think I completely agree with both your takes. It's like, I think we're super early stage. I think bubbles are good, honestly. I like that capital investment. There's a lag time, right, from capital investment to like actual value. It's like the internet. The internet companies didn't like think about like cloud came from the internet, and that was like in like the 2010 era, and then the dot-com bubble was 10 years before that. It's just these effects that you have no idea about. But cool. I've got some maybe other topics if you wanted to bring those up and as well. But
yeah,
I don't know if you had any other ones, Illia.
No, I think we can discuss those.
Cool. I think another fun one was I was just curious about this one for maybe you, Illia, and Henry, and then myself. What are you making bets on in the future? Like, where are you making investment? Not capital investment, just like maybe energy or what else? Or like, but what do you think is going to really be a really cool area that is like uniquely your opinion or your take? So what's NEAR betting on? What's NetMind betting on? And I can maybe give a take on what Arize is betting on.
Do you want to go first, Henry?
Yeah, that's a great question. But so like this is also related to AI, right? So like in AI domain, right?
Yeah, in the AI domain.
Okay, cool. Yeah, that's a great question. So for me, one of the because like we are building a decentralized infrastructure, and also we are focusing on offering AI service in decentralized domain, right? So one of the I would say opportunity or the thing that I think it could take off in the future is the decentralized AI. So there are several aspects in decentralized AI, right? So one thing is like is the decentralized infrastructure. So basically, like so unlike the traditional cloud computing, where all those kind of GPU machine and GPU power are sort of controlled and like sort of like controlled by the big tech company. So decentralized like GPU network, all those kind of GPU are contributed by the GPU owners, and then this like creates a large machine pool. And on top of those like large machine pools, like we build reliable and scalable decentralized and distributed computing infrastructure. So this is actually a really good point that we can offer much cheaper price and easy access for GPU users. And also like we build a variety of AI services on top of the decentralized infrastructure, like GPU, like for example, training, fine tune, and inference, right? So with this kind of robust infrastructure and AI services, like people can use the AI service in a much cheaper price and affordable and flexible way. So like we are like spend lots of time and resource in investigating or researching some cutting edge technology, for example, asynchronous training and also serverless inference. So like those are sort of like combined with our decentralized infrastructure, which are very interesting and also can sort of like lower the GPU cost a lot. And like I think like for the like for example asynchronous training, right? So this can sort of like improve the training efficiency by split the model and also split the data, and also eventually make the training in asynchronous way to reduce the high speed and high bandwidth connection required by the traditional steps. And also like for serverless training, right? So like for decentralized network, inference is one of the biggest scenario for making use of all those kind of decentralized machine and GPU power. So we built a sort of like a serverless inference platform that can maximize the use of GPU resources, and also sort of like we sort of like investigating the like model loading, model inference acceleration technology, and those kind of thing combined with our decentralized infrastructure can sort of like also meet the growth demands without being limited by the centralized GPU supply issues. And we also partnership with data centers and individual contributors to ensure a steady and scalable supply of computing power. So basically, I think there are lots of interesting topic for decentralized AI, ranging from infrastructure, model, and research, and those are all those kind of thing. I think like has a big potential in the future. Yeah.
Yeah, I actually like that take. I think whenever you guys were talking about like you have to be one of these big players in order to come in here. I think decentralizing some of this would be super, super nice. So I really do like that take. It's like, I think democratization is like a very common theme over the last 25 years.
Yeah.
To be very honest, like democratization of everything. Like, I think Hollywood's going to be changed in the next 5 years pretty significantly, and the rest. But I really like that take, and I like the way kind of you're going about it. I'll go second just to keep it different. We'll make Illia go last. But what's a recent bet that we've made? We'll play a fun little game with y'all. How many softwares do you think you interact with in a day? Like, just give me a number, both of y'all.
25?
Probably hundreds if you include all the different website servers.
Well, website, okay. Then like
probably a lot, right?
Yeah, over 100.
And so like here at Arize, we do observability, right? We let you know when, we started off in the classic ML world. Obviously this Gen AI space, we were doing NLP before even 3.5 came out. So we were like really well set for this wave. And so when I think about some of the bets we've made, and it's like, when you think about how do we observe software today, right? The myriad of softwares you work with. Well, we use software for that, right? We use things like Datadog. We use things like, open telemetry. So we use software to observe software today. And then now my next question to you two is, in 5 or maybe 10 years, how many AIs do you think you'll interact with in a day? Give me a number.
Hundreds.
All right, probably the same amount, right? So what was our bet here? Our bet was really like, do you think it's and this is like a fun question. This is really like, do you think we're going to use software to observe these AIs, right? And our take was no. our take was like, no, you need something of equal intelligence, right? And so we started working on our Copilot. So in the same way we have observability tools to go and let you know, like, hey, these are where like you're hallucinating. Like everybody here has probably run an LM as a judge eval on like their AI. We actually built, for example, an AI whose one job is to troubleshoot and observe other AI systems. So like a little bit of AIception. And so it's been really fun building that out. We had a big launch maybe 2 weeks ago. But the idea was like, yeah, I think it was like a stepping stone into something a little bit more scalable. Because if you imagine these things, they're non-deterministic systems. If you want to think of them like humans, it's like, well, how do we police and observe other humans? And it's probably another human, I think, in like police versus citizens kind of thing. And so in terms of an area, I've heard people talk about this. I think the Glean of CEO, Arvin, and then I think Richard No, he shares my last name, but he's like, he was on the AI alignment team at OpenAI, still is actually, talking about like, if we scale this out into the future, what does, like, how do we make sure these things that we've built kind of performing in the way that we expect? So that was a big bet that we made recently, and it was been pretty exciting building it. And just we had a lot of learnings, a lot of failures, a lot of successes, but that's one area that we've made a bet in.
Yeah, no, I mean, totally makes sense as the complexity and intelligence of the software enhances. I mean, in a way, we had this on last week's episode. I was like, agents are just, APIs, which are, instead of syntactic, are semantic now. And
Right.
so you kind of need all of the software that was syntactic before and was monitoring syntactic things or interacting in syntactic ways. You now need them to be moving up into semantic space. Yeah, I guess I'll go on my side. So last year, I was really excited about edge models, and kind of this was before, I would say, like 7B were gotten like way smarter. And so we kind of started this edge intelligence community, right? That has an office in San Francisco now, and really kind of working kind of across few projects that are doing work in this space, both on more, hey, how do we bring kind of from a privacy perspective, like how do we keep data on a device and then bring the model to the data and make it actually better, like results for the user and for advertiser, for recommendation system, for whatever you're doing on the other side, right? For product. So how do we make it more private, cheaper to run because you don't have inference costs and data storage costs, and better results, better clicks-through ratio, right? So Cosmos is doing, for example, this in a very interesting way, and they're going to be coming out with like a separate product for that. And there's like a few others who are kind of in this more edge models. And obviously, the space kind of caught up fine-tuning these models. And I'm interested in this even more for kind of the next stage, because I think, I'm in a way disappointed that like we're using exactly the same stuff we've done, right, for like past 10 years of deep learning, which is like we just hammer with gradient descent and and like babysit learning rate. There's a little bit of like advancements, but like Adam has been around for a while, right? And that's the last advancement we've had in learning algorithms. And so from my perspective, that's kind of the missing piece right now. Is I think we have like the model architecture is okay. You can, there's obviously some really good ideas coming up, but I think the problem now is how we're training these models. And so there's an interesting combination of learning algorithm and kind of synthetic data preparation that I think will actually allow us to have smaller models to be even more intelligent. So we've already seen that, right? Like, you take 400B model, you synthetically generate data to train 7B model and get better, right? And so I think we'll see that kind of progression continue happening, especially if we like go away from pure SGD, right? But actually leverage a bit better kind of update algorithm for parameters. And so there I'm interested, like, I mean, I've been reading a lot both on like what is the meta learning algorithms right now are, what are the, also there's people like researching on how kind of, you know, universality of parameters and how like if you train different models and different modalities, there's actually, you know, the features learned are, you know, some kind of potentially a fine transposition of each other. So like there is some learning that's happening that like is, you know, I kind of, the way to think about it, I mean, in the geometric space, right, it's trying to find this global minima, right? And so like that global, like how do we navigate to that global minima faster than, you know, hammering with thousands of examples of the same thing, right? The model. And finally, because you mentioned the observability, and one of the things that we really critically need is making sure that models, agents, and in general code that runs is correct. And I think we will have some of this more semantic, but we also need formal verification. And so that's something that my co-founder Alex looks a lot at. How do we actually introduce formal verification? And like realistically, people will not write formal proofs for the code written, and the code written itself will be AI generated. So like we need AI to generate formal proofs, and the benefit of this formal proofs is actually they're self-consistent, right?
Right.
If you have like the right, you know, preconditions that you want to validate, like it's either works or not. And so that has like it kind of similar to like ZK, you know, recursive proofs, right? Like if you can prove the some condition, then everything underneath is correct as well. And so I think that's going to be fundamental for us to be able to compose this, especially more complicated kind of software behaviors and intelligent software behaviors that like, hey, it can maintain this set of, you know, preconditions or post conditions even after whatever AI magic is happening in the middle, but it's not going to spend more than this much of your money, for example, or it's not going to go and like try to start a war or something, right? It's gonna stay in this, you know, specific set of conditions. So I think that's, and again, this is important because most of human written code has bugs, and so like we kind of need to rewrite all of that, and the only way to do that now is with AI. And so we will need to have validated code there. So that's kind of how I'm thinking about, like, you know, like edge models, making them smaller and making them smarter through better updates. And then on the other side, using all of that to actually build better software, build better, and that is formally verified.
Yeah. Illia, do you imagine that I guess the purpose, what's for the everyday, you know, layman, where do you think these edge models will really help out? I mean, like on device, on phone, like that seems like the natural first step. But where do you think, like, do you think it can go into other parts of like industry? Like, I don't know, you have computers everywhere, right? So is it just like, even in like, I don't know, chemical refining or construction, or is that where you see really a lot of the value for these smaller edge models going?
I think it's definitely the consumer part going to come first, just because it's like the cost of running, like imagine you're running like a, you know, 100 million user app. Like if you need to serve AI inference on GPUs, like, I mean, it's just going to be like expensive and either way, right? So you want to push the cost on the user side. And so, and again, I mean, this is why, like, you know, Apple Intelligence is a good example of kind of moving in that direction. But I think like we need that to be open source. We need that to be like accessible to every app, not just like operating system kind of controlled and gated. So I think that would be the step one. The step two for sure will be like just a new type of software, right? As you mentioned, right? It's going to be like LLM inside, right? And so like when you deploy stuff, you're going to deploy it like combination of, you know, kind of agentic framework with LLM, and that's a software that's going to run on something. Right? And you want some observability and some set of things that it's not going to like blow up your plant.
Yeah.
Sure that, right? But that this way it actually like is able to handle all of the like errors in situations which like software cannot, and then you like need to escalate to a human. And again, there you don't want to go to hit some API that may go down. You don't want to leak all your data that somebody can then use, either maliciously or for trading or for anything else, like insider trading type thing. So like you want to have as much local control and privacy as possible. And so similarly with companies, right? Like we're running, internal search AI powered, right? Like I don't want this to run on, hitting OpenAI. I want to run it in my cloud on top of my data. And so like I want an open source model. I want this, but ideally, it's like robust enough that I can run it on kind of small enough GPUs. So I think like it is gonna kind of propagate everywhere.
Yeah, it's like you need the variability. Like I think there's advantages to being like just running everything, economies of scale, right? The same reason why cloud works, but there's also advantages of like being distributed, right? And I think you serve different markets that way. Your other take too, just wanted to add a comment on like what we see in the space too is like about like making sure software or in this case agents behave as intended. Yeah, I think when you think about the solution space of like a fully autonomous agent, right? When we talk about like the planning stage, execution, and then reflection and all that stuff, I think we all know that like fully autonomous agents kind of suck right now. And then you're exactly right. What we see happen in the enterprise is people bound the problem down because like if you want deterministic behavior from something is like not deterministic, you kind of have to bound it a little bit. So I think a lot of people, here's my hot take, is like a lot of people like use LLMs too much for things. Like, what else is like really good at orchestrating and executing? It's like code, like just normal code. Whereas like I think LLMs are very good at like interfacing with a human in like unstructured text. So I definitely agree with you on that one. I think we need to mature out some of the frameworks too. I think there's like, it's like either fully autonomous, like agent can plan its own thing. And then what works in the enterprise today, which is these like router where you've bounded the problem, like you can do X, Y, and Z. I think you're right, Illia. There's like some place in between like, hey, here's your box. And like, you can live anywhere inside that box, but it has to be inside this box. But that was my take.
Yeah. So yeah, I think I do have some idea about edge. So like edge computing is pretty interesting, and also like I agree that like for most of the so there's a trend for the model to be smaller and to be capable of doing things like agent, right? But it's sort of like much smaller than like the like trillion or like llama 4.5b. So it's really not that like it's too much for a like for that to solve a specific task or specific thing, right? So in the future, like the smaller model can sort of become more capable like to doing things, and also be much like cheaper and also much smaller to run small devices. So like we like NetMind also are investigating how to fully leverage all those kind of edge device, because like for edge device, like they are sort of like consumer or even consumer brand GPU or even like CPU. They can also sort of like contribute their computing power to like our platform, and like we can leverage their computing power to do, for example, model inference. So but as I agree that like security and data privacy is really, really important. Like we don't want to risk like customers like data or any of these kind of data to leak in the users devices. So but like we are investigating how to connect more and more different kinds of edge devices to our GPU network, and also run inference on top of them, but also ensuring the privacy and security. Imagine like in the future, like there are sort of like tons of like decentralized like device clusters, and with a sort of like security and all this kind of compliance built on top, and then like everybody can just like use all those kind of services in a multi-region and decentralized way, and then like and we have hybrid model, like for smaller model to solve specific task, and for tasks that they cannot solve, maybe they can just like use like larger model or use different kind of models. But eventually we want to build all those kind of clusters with cluster federation, and then to serve all those kind of inference with a secure way. So that's actually one of is in our roadmap, but I think it's challenging, but I think it has very big potential. Yeah.
Awesome.
I'm curious actually on this side and in general, how are you thinking about new hardware, new types of hardware, as well as kind of evolution, as well as kind of cost structure on existing hardware? Because I was actually trying to do some math, and from my understanding, if it's not the smallest model, and like if we're talking about kind of 70B, for example, on previous, like not the A100s, but like previous generation, like 4090, 3080, like you're getting a pretty like really bad performance, right? You're getting like 2 tokens per second kind of thing out of 70B model, right? Which, given the cost kind of is defined by H100s at this point, it's not that much revenue being made. So there's like pretty massive opportunity cost slash just like electricity cost that comes into this. So I'm curious kind of how you see that, how you see new hardware coming in, which maybe have different properties, or is kind of provides different trade-offs.
Yeah, so like I think I agree that like so if you want to have like the best performance, you need to use the hybrid GPU like H100, A100. But for inference, like because like we with the latest like model acceleration technology, it actually can get like relatively good performance on like 4090. If you just like for example inference a 40B 70B model, also like
what do when you say good performance, what's the rough numbers?
So there is like I think like I cannot get the real like concrete number for that. It depends on the model, right? But I think like it's not really bad, as you mentioned. Like you get like 2-second latency for the first token. So
I meant like 2 tokens per second. That's kind of with the speculative decoding using 7B and 70B, like the model, it's like two tokens per second on.
Yeah, so like if you search the like latest model acceleration benchmark, I think it's much better performance than like 2 seconds per token. So yeah, and I can say that because like we actually did a bunch of testing and benchmark for model acceleration, and also like we because there are like lots of open source framework you can use for accelerating the inference, and I also want to talk about the serverless. So because like like you can actually serve the model in a serverless way that that like you can sort of like make full use of all those kind of GPU, and also like so like I'm not sure if you know like the Lambda in AWS, right? So like people are really interested in like using the serverless by saving the money, because like if you use the if you are enterprise customer, right, there are a bunch of way to use the inference API. You can sort of like use a dedicated server, like you pay for a GPU server like H100 or A100 daily or hourly, and then this is like your specific server to serve your API, inference API. But you can also just like pay for the use and use the serverless. So in this way, like it's actually give you a space to loading the model dynamically, and then to sort of like make full use of the GPU and to serve different kind of customers. So this actually can sort of like save money in terms of the infrastructure side. And also like I think for new GPU, right? I believe like I believe like I'm not sure like how because like the hardware and the AI model are evolving together, like with the high performance GPU come out, we can have like much bigger or better model, which can sort of like depends on those kind of hardware. So yeah, it's pretty tricky to um, to 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 see the future. But I think like the model can be much smaller, and then eventually I hope that like in the future we can have like the smaller device or edge device can run fairly good model, and with or without GPU. Yeah, that's my take.
Yeah, I think that's the whole your comment about like how the I guess model inference model training is really adapted to the hardware that you're on. Since you're on that side of the space, Henry, where do you feel like how much more innovation are we going to get from the hardware side? What's your like hot take?
Yeah,
I don't know. Like, are we maxing out? Like, is NVIDIA like? Are we still early stages? Like, I definitely know from the application side, from where I sit, it's super early stages, right? But on your
yeah.
side,
Like I heard some news that like the architecture can be changed for specific or type of models. Like for example, like the GPU for LLM. I think like this can be the opportunity or potential for to sort of like accelerate the GPU performance. So yeah, but I know like we are sort of reach a limitation because I'm not an expert in hardware. I don't know how far we can reach to the limitation, but I, I I'm thinking like maybe Nvidia or other big tech company can come up with some like new architecture specific for AI models, right? And
There's a couple startups that are doing that,
yeah,
like
exactly.
specifically for transformers. The challenge there is like, and this is true also with some of the other competitors who've been trying to build kind of AI specific accelerators, is that it's really hard to do research on them because like it kind of anything beyond just like a standard, whatever Llama does, anything you try to do is like blows up one way or another. And so and what it means is like all the code that researchers write that then goes into becoming a next model is not written for that hardware. And so there's like a very weird kind of negative loop there. And so, and because these things have, I mean, come on, this has been 2 years since people started like seriously looking at this stuff. The reality is like whoever's targeting stuff, like, the time to design, to tape out, to get prototypes, to get production ready, like that usually takes like 1.5 2 years. So by the time they do that, the research already moved on, right? Somebody comes up is like, hey, actually instead of attention, we should use whatever this thing, right? And boom, it like now you literally design and build a company. So it's kind of a, like, in a way it's a high bet that, like, high risk bet that you're like, hey, I'm gonna like optimize for this architecture and then hope that it's not gonna change for 2 years fundamentally. And so that's like, as you said, right, the software is just evolving so quickly that is just like, it's a very risky bet. And like, I mean, there's some people taking it, and obviously VCs have funded that, just because like Nvidia has such a massive earning. But if you talk about like generic GPU, like generic mass processor, right, that you can do anything with, the real challenge is software. CUDA has been like chiseled out for 10, 20 years, right, into like what it is now.
Yeah.
And a lot of people kind of like AMD and others are trying to catch up, and the hardware is probably like, maybe not one-to-one, but like comparable. And it's just like, again, software problems is like kind of killing productivity. And so, but I think like for AMD, and for few others, it's like, if you go production and you need to do it at high scale, you can do it, because like it's worth investment into like fixing all of the issues down the stack, and like, fixing drivers and fixing like whatever. But if you're doing like research and you're kind of pushing the envelope, right, it's not. And so that's kind of the trade-off.
Yeah. I agree. If you look at the pace of innovation from like model builders, like it's very clear like Anthropic has caught up, right, in a very short amount of time. But no one's like AMD is nowhere near close. Like, yeah, AMD is nowhere near close to Nvidia. Don't even get me started on Intel. So, but, yeah, those are my two fun questions. But I'm happy to open up the floor to Illia. This is your show, so.
Yeah, no, I mean, I like it. The idea to have discussion on some of these topics that's top of mind. So I don't know, Henry, if you have any top of mind questions on your side.
Yeah, I think like I do have one topic I want to discuss. So so I want to like bring up a topic about AGI. So yeah, I know it's a very broad like topic, but what do you think about AGI? Like, what's the challenges for eventually achieving AGI, and what would be the opportunities and also like the barriers to achieve the AGI? Yeah.
I guess my first question is, how do you define AGI?
Yeah, but like AGI is just AGI, right? Like, or like I want to say like AGI is something like the AI has like really high intelligence, and it can just like do what, or it can sort of achieve what human can do for like tasks, for like helping human to do things. Yeah.
Yeah, I mean, my formal definition is it's a system that is able, a digital system that is able to do anything that human can do in digital realm better than the best human.
Interesting take. I feel like I have like many lenses that I want to look through. It's like, if you're saying like, can this, like, I don't know, can an LLM outperform a human on an IQ test, right? Well, technically we're at AGI because it outperforms some humans. I don't think we have AGI until this thing has intention. That's where I think it's like it's conscious and can decide like go for
yeah,
it.
I mean, I would argue that like the intention consciousness is not the requirement for having something that is generally intelligent.
For sure. Fair enough. I see that take, but I don't know. It's like, artificial general intelligence. I don't know. It just depends on where you draw the line, I guess.
Well, that's what I'm saying. Like it should be able to do any task, any skill in digital realm better than a best human at that skill and task.
Oh, okay. Better than all humans at that task.
Yeah. So like if for that skill there's the best human in the world, it should be better than that.
Okay, we're definitely not there yet, but okay, fair enough.
We're not. No.
What if the skill is like intending to do stuff? You know what I mean, Illia? So it's like, I'm just saying. I think intention, to me, it's in there. It's like, that's my definition. But
I think why I don't agree with that is because the intention may come from the user, and and then in this case, AGI is still a tool, right? Like what you're saying is like, hey, it's a sentient being, right?
Yeah.
And like you can imagine a sentient being that actually is not that intelligent, like a dog. Like dog is not very intelligent.
Okay, that's a good
very
distinction.
intelligent, but it has a very much intention.
Okay, that's a good point. I kind of retract back what I'm saying. But yeah, I think my take on AGI is like, I don't know. I see this stuff in the wild. We're kind of nowhere near it, to be very honest. Like getting actual in production LLM applications to work, even something as simple as like RAG, people still struggle with it. It's like the latest flavor of like, oh, how do I get it's like graph RAG is all the rage the last 2 months. So my take is like we're still early stage. I think like is transformers part of the equation? It's like super possible. I think it was a big unlock, but there's so much. And here's another hot take. I feel like so much attention is on like LLMs that we've lost like investment into other areas. And it's kind of like we're more homogeneous now. We're like all focused on this, where I think as before it was like kind of more widespread. So I think we're very far away from it. The direction's okay. I mean, but I think we just need more investment into other areas. Like I think there's a lot of promising areas outside of like transformers, but no offense, Illia, but
No, I mean, again, for me, like as you said, like it is, transformers or some deep learning architecture is a component of the system, but it's not going to be the whole system. Like for me, the things that like if we would design it right now, right, just like kind of high level, you want something that is able to obviously like use tools and process data, etc. And the reality is like the current models are not trained to do that, right? Like yes, we fine-tune it a little bit, we like put a little bit over it, but the reality is like if you think of like the way this model is trained is it's like if you were getting dropped into a new room every like 30 seconds, and then you need to like find the like and touch 3 pieces of furniture, and then you drop to the next room, and then you're like, okay, build me a great furniture like furnished apartment. It's like you don't actually know why this article was written when you're trying to generate it. And so I think there's like definitely better training procedure. That's kind of what I was saying, right? Is like how to update parameters, but also like how the procedure is done versus like text token protection. There is some form of search and kind of self-evaluation that needs to exist, because this is how you're going to find new things. It's not going to be because you're just like rolling the tokens. And this is what we see with all of this IMO stuff and other things. Some type of world model, right? Again, transformers maintain a form of a world model in parameters, but it's very it's limiting in the sense that like you don't update it from the inference, right? So like how do we do active learning now and is that then should live in parameters, should be in activations? Like should we have like all of the activations ever be available? Well, that doesn't make sense. Like, okay, well, how do you compress that into either parameters or something else? So all of those like things is where, as you said, it feels like the research kind of a little bit like narrowed down versus like investigating. I mean, some people do, but like it's not enough. And actually, this is something we are looking at, is like how do we accelerate open source research? Because from my perspective, the challenge is that in universities and in general open source world outside of 3 big labs, you actually don't have much capacity to even experiment with these things.
And it's felt less open source over the last 18 months.
Oh yeah, exactly.
It's like no one wants to share anything, and it's like I don't really like the direction we're going. It's like the opposite in what like these companies have like, oh, we're gonna, it's like the opposite direction which they plan to go. It's funny, like the path to hell is paved with good intentions, but you're still on your way to hell.
Well, yeah, I mean that's why like the business incentives of big companies, right? And I mean Meta thankfully has like business incentives to that are opposite, but yeah, I think again, I mean this is something we're working on, is both coordinating a bunch of people, but also like how do we create an environment where researchers can actually work together and then benefit in some way from the research they've created, and also have resources to be able to do experiments at scale, right? And have new data. So yeah, I think that is something we really need going forward. But
Yeah, that decentralization piece is super important there. Like, let's democratize a lot of this stuff via like sharing. Henry, what's your
I
take?
think
Oh yeah, we're out of time, right?
yeah, we're out of time. So
All right,
yeah,
Henry.
thanks guys for joining. It was an amazing discussion. Some hot takes. I'm sure we'll see some of that on YouTube and in short videos now. But yeah, exciting to be building this with you guys.
Awesome. Likewise. Thanks for having us
Thank
on.
you.
Cheers.
Nice.